We're going to go to our final presenter here. I know we're running a little bit behind today, but I don't think it'll be any worse off for it. We've got Oscar here, also from Equinix Developer Relations Engineering. Oscar, are you on the line with us here?
Hey, hi everyone. Thanks for having me.
And you don't have 12 sources of mute, so we can hear you immediately. It's so good.
That's good.
So, Oscar, you're going to chat with us today, automating secure connectivity, right? So we're talking interconnecting clouds, it looks like?
Yeah, we are going to try that at least.
Awesome. Well, I'll let you introduce it yourself and go from here, and I'll hop off for this one.
Okay, well, thanks. I'm going to start sharing my screen, if you don't mind.
No, of course, we'll get the screen up and make sure that's all working. And I think we're diving a bit into using Terraform with this one as well, right? So we'll close the loop on the full like Pulumi cross-plane Terraform. I think we mentioned OpenTofu, and our Terraform provider works for that too. So if that's people's preferred flavor, we can do Equinix Metal stuff on all of that.
Yep, I think we have covered at least all these main or important ones, right?
Yeah, great.
So, so thanks for having me. I'm going to start sharing a little bit about me, even you have already introduced me. My name is Oscar Cobles. I'm a software engineer here at Equinix. I'm working on the integrations engineer team under developer relations. And here, well, you can find my contact details in case anyone would like to chat after the session. Hopefully not today because I'm based in Spain. It's a bit late, but from tomorrow, anytime. So, I'm very excited to have the opportunity to walk you through a practical use case of Fabric Cloud Router. Let me share again the title of this talk. It is Automate Secure Connectivity between Equinix Metal to AWS via Terraform and Equinix Fabric Cloud Router. So I know there's tons of words there, but I promise you they're all important. But for now, we're going to put focus on the last part, Terraform and Equinix Fabric Cloud Routers, because they are going to be the real takeaways of this session. So I'm going to briefly introduce them both. It's going to be just a couple of slides, 4 of them to be fair. So let's move on. Well, even though the majority of you may know about Terraform, you are familiar with Terraform at least. I would like to introduce very quickly because I want to make sure that everyone is on the same page before going ahead. So Terraform is a powerful HashiCorp tool that let us define and provision in our infrastructure using a high-level language. So it essentially let us manage our infrastructure through code. Terraform acts as an API consumer, interacting with the different cloud and service providers like Equinix, AWS, Azure, Google, and perhaps anything or anyone that you may have on mind, and letting us to deploy resources in their platforms. So we can achieve that using declarative configuration files. They look very similar to a YAML file where we define all the state that we want to achieve in those platforms. And once we have defined all the configuration, we just need to run a command, Terraform apply, and that will create all the stuff on your behalf. So, and what about Fabric Cloud Router? Fabric Cloud Router is, we can say FCR from now on. It's a virtual routing service available on Equinix Fabric that let you create a interconnection and route the traffic between different cloud providers or service providers available in the Equinix Fabric ecosystem, like all the major cloud providers, and also between the Equinix data centers digital services, like it could be Network Edge or Equinix Metal Fabric Port. It's available in multiple locations all around the world. And what's important here is there's no license required. It's fully managed, and there's no commitments or termination fees. So we we distinguish between two different main use cases. The first one is the cloud to cloud or multi-cloud connectivity. So in this case, the Fabric Cloud Router, it's going to work as a central point to route traffic between the different clouds. So in this case, in this picture, we have an example of two clouds, but it could be multiple of them. So it could be, you can have a setup with 4 or 5 cloud providers using this single interface to connect between them. There's another important use case is the hybrid cloud, which is partially what we are going to try later during the demo. And that will be part of what you can see in this picture, where we are going to try to connect between establish a private interconnection between between one AWS service and an Equinix Metal server. But you can also can create this kind of infrastructure where you will expand your cloud to new cloud location using multiple Fabric Cloud routers and or IP1 multi-point service. So now let's move on the demo diagram. This is what we want to achieve today. So let me explain a little bit about the different resources that we have in this picture. Starting from the right side to the left, we have the first thing that we find is an Equinix Metal device that we have. In this case, we have set up with an Ubuntu operating system. And there, we are going to use this device to test the private interconnection to the Amazon S3 bucket that you can see on the top left of the screen. And we have also created, or we have also deployed a routing service in this Metal device. I will go deeper on that later during the demo. So continuing to the left, the next thing is we are going to have is a Fabric Cloud Router with 2 Fabric interconnections. So that will help us interconnect between route traffic between the Equinix Metal and the AWS side. Then in the AWS box, there is, you can see there are several components. The first thing that we find is a direct connect gateway and a VPN gateway. It's called the Virtual Private Gateway in Amazon. That is the one that let us associate one direct connect gateway to a VPC. So during the direct connect gateway is where we are going to configure a virtual private interface. That's the one that let us configure a BGP session between AWS and the Fabric Cloud Router. And then continuing to down to the purple box. This is also an important piece of this session. We are going to use AWS Private Link. So perhaps some of you are already familiar with with direct connect and how you what you need to create to interact with public services like S3. And in the past, the only option available to do that, to connect to one of these public services from a direct connect, was using a public virtual interface. So that implies that you need to define a public peering with public addresses, and that's not longer needed. So with the private link, we can use a private interface, and we can still use a private subnet to consume those services, both from, or in this case, from Equinix, or from our Equinix Metal device, and also from inside the VPC. So you can use the same private link endpoint to connect from the EC2 instances. So if you have already a service running in EC2 and you need to extend that to Equinix Metal, but you want to keep storing your data in S3, you can use the same endpoint for them both. So, well, as promised, I'm going to move now to the demo part. Here you have the link to the code that we are going to use to run this demo. I'll try to put that later on the chat, or well, for sure I will share this slide also at the very end of the session. So give me one moment, because I'm going to move now to Visual Studio Code. Yeah, let me switch over on the other side. Okay. Well, you need to
increase the font size a couple ticks. It'd be perfect.
Yeah, let me try. Is it better?
Yeah, more. Yeah, perfect. Right there is good.
Okay. Too much for me now, right? So, so here we have our code. Well, you can see that we have split our code in several TF files. This is not really a Terraform requirement, so you can actually put all the code in a single file. But for sure, this will help you keep it more maintainable. So in my case, I decided to split the code by creating a different file for each of the services in both Equinix and AWS, those services that we are going to interact with. So I would like to walk you through the code a little bit, at least on the most important pieces of this setup. So again, I'm going to start from the Metal configuration. So what we have here, the first resource that you can find is an Equinix Metal VLAN. We need a VLAN because it's required to establish a layer 2 connection between our Metal device to the Fabric Cloud Router. And the way to achieve that using Terraform is this way. So if it's the first time that you are seeing a Terraform template and the code and how it works, well, it's always the same. Doesn't matter the resource that you're creating or the cloud service or the service provider that you are interacting with. So you need always to define a block like this one, where you specify the ID of the resource that you need to create, in this case an Equinix Metal VLAN. Then you need to specify a name for that resource. So this is just at the configuration template level. So it means that if, for example, in my setup, I need a couple of resources at VLANs, I will just create 2 of them with different names. Okay, much better. And then what else? So we need to specify the parameters to configure that resource. In the case of the Metal VLAN, the only thing that we need there is to specify the metro and the project where we want this VLAN to belong. And well, as you can notice also, there's for the value of the metro project ID, I'm using variables. This is also a good practice in Terraform. Instead of hard coding here the values and make the template more reusable, you can define variables that can be override during the deployment, and you can define also a default value for them. So during this deployment, we're going to use the Silicon Valley metro for all the deployment, and well, we will go over the different variables that we have here later. Coming back to the Metal file, the next thing important is the resource for to create an Equinix Metal device. So, as I said before, then with the diagram, we are going to use this one to test our connectivity to the S3 bucket from Equinix, establishing that private interconnection from Metal. Well, there's some required variables also here, like the operating system, and we are going to use Ubuntu 24, and also Silicon Valley, and the size of the server. In this case, I just choose a C3 small server. And perhaps the most important point here is that we are using the user data field. This is a way that the user data in Equinix Metal let us execute some task during the deployment of the server, and you can do that using a shell script, or it could be a cloud init config file, which is my case. So before going to show you what is included in this user data template, let me show you the next resource. Here we are going to configure an Equinix Metal port. A little bit about this. When you deploy a new server on Equinix Metal, it always default comes with a layer 3 connectivity. So if we're going to modify that behavior, we need to use this resource. In my case, since I want to keep, for this deployment, I want to keep the internet connectivity from my server to consume the DNS of the Amazon S3. And also I need a VLAN to interact with the Fabric Cloud Router. Then I want to modify the network configuration of my device to the hybrid bonded mode, where, well, as I said, I'm going to put my bonded interface with both layer 2 and layer 3 traffic to support them both. But this is to configure the network at the physical level of the device. But we need to also configure the network at the operating system level. So that's why we are using this user data. So let me show you what's included in that template. So there are two main pieces in here. So the first one is where we are going to configure an interface for that bonded specific VLAN tag. You don't need to modify any of this, because as you can see, we are using a Jinja template, so it's going to replace all these variables with the inputs that we have defined in the in here with these values. And then we have also this part where we are configuring an FRR, which is a routing service. And you may wondering why we need this. So in Equinix, we actually have in Equinix Metal, we have a virtual routing and forwarding service, VRF. But for now, it's not compatible with Fabric Cloud Router. So there are some alternatives. One of them is to configure, in this case, that we are just making an example. It's a simple setup. We can just create or deploy a virtual routing service on our server. It could be FRR, but there are other good options like BERT. You can find all this in the Equinix documentation. And the other option, when you have a more production ready setup, we have also the ability to deploy a dedicated server with by OS. So you can route all the traffic from the different Metal devices through that one. So going back to the Metal file, the last resource that we are defining here is the Equinix Metal connection. This is the connection from Equinix Metal to the Fabric Cloud Router. So moving now to the Fabric file. Here's the first thing that we have is an Equinix Fabric Cloud Router. You can see, it's not difficult. You also in the documentation on the Terraform registry have the different values that are available for each one of these fields. And here we have also using a module to establish the connection and or to configure that connection in the Equinix Fabric site. So anytime that you are configuring a new Fabric connection, you need to configure that in both ends of the connection. In this case, in Metal, and here in Equinix Fabric. So you can notice also that in this parameter for the authentication key, we are retrieving that value from the Equinix Metal connection. It's the authorization code that we retrieve once we have created the metal connection request. And if I move down where we are configuring the connection to from the Fabric Cloud Router to AWS, well, this is different. So in this case, if you take a look on the authentication key, you can see that instead of using an authorization key, we are just using the AWS account ID. That's because, well, in the case of AWS, to the connection request starts at in Equinix Fabric, and then if we move now to the direct connect file, you will see that the first thing that we need to do after requesting that connection from Fabric is to go to the AWS site and confirm that connection. So if you go to the AWS portal, you will see that there is a new request, and you can just accept that connection or deny it. And just a few resources that here important here in the AWS site. So we need to configure our private virtual interface. So here where we put the details to establish the BGP session between the Fabric Cloud Router and AWS Direct Connect, and some other resources that we need to associate that virtual gateway with our VPC. In this case, for this template, I'm just using the default AWS default VPC that we have in my account. But well, we can override that to create a new VPC, or just using the one that it's already existing, specifying the ID of the VPC. Then now let me move to the private link. As I said before, it's also an important piece of this deployment. So we don't need that public virtual interface anymore. Instead, we just need to define a VPC endpoint. And here, well, we specify the service that we want to connect with. In this case, it will be an S3 bucket. It's almost always the same format for the service name. So in case, for example, you want to consume or to interact with a DynamoDB, it will be com.amazonaws. The region and the DynamoDB. So anyway, you have all the list of all the services names in the AWS documentation. So here we create an endpoint of type interface, and the only thing left here is that anytime that you create a new VPC endpoint, you need to also to specify the security group. So we want to make sure that we allowed the traffic from the Metal BGP peer subnet. So if we go back to the user data on Metal, you will see that we are using the same that subnet to configure our server. So once we have all this documentation, all this configuration, let me move to the S3 file. This is the last one. So here, well, there are some resources that are required to create the S3 bucket. And what's important here is that we are defining a policy to explicitly deny all traffic to create a new object or to retrieve an object from this bucket that we are creating, unless it comes through the VPC endpoint that we have created. So in this way, we are going to make sure that all the connections to interact with our S3 bucket are coming from the private network. So now that I have explained a little bit what we have in our code, the next step will be to apply this configuration through the, as I said before, through the Terraform apply. So the first command that we need for that will be, we will need to run Terraform init. Terraform init is in charge of downloading all the providers and plugins and modules that we are using in our template. And the next step will be run a Terraform apply to create all this stuff in both the Equinix and AWS platform. So since this usually takes around 15 or 20 minutes to deploy this template, I did that before the demo. You can see that when I run Terraform apply, it says that there's no new changes because it's already created. So I have created almost everything, but If I don't know if you noticed this before in the Fabric file, but I have commented a couple of resources. This is the configuration of the BGP on the Fabric Cloud Router side. So if I go to the Equinix Fabric portal, you will see it says that both connections in my Fabric Cloud Router are pending of interface configuration. So let me SSH connect to the metal device. I just going. So of course this is one. It's not going to work right now because we need to conclude that configuration. But let's try and see what happens. So as part of the deployment, I have created also this SSH key, and it will be deleted before once I run Terraform destroy. So I need to use this public IP to connect to my server. Also, let me show you. In the metal user data template, we have also installed the AWS CLI, and I have already configured that before this session, so it already have my credentials. So if I run now, for example, AWS S3 LS, it will list the different buckets. So it's working because, as I said, I have the AWS CLI configured with my credentials, and I have access to list all them. So if this is the one I have created in this demo. If I try to list the resources in there, it will work too. But there's no resources right now. So what happens if I try to add a new object to that bucket? Let's try it with the hello metal. I'm going to create a new file that I'm going to try to push that into the bucket. I'm going to call it demo. And now I'm going to run the AWS S3 copy. Okay. Demo to the S3 demo day bucket. Well, as you can see, I can do it, but it's failing because it says that there is a explicit deny. So how we can solve that? So how we can ensure that we are using the endpoint that we have created to interact with the S3 bucket? For that, we need to add to this command. We need to specify the endpoint URL. So if I go to the Terraform outputs, this is the S3 endpoint URL that I have created. Well, it's not going to work because, as I said, we need to configure the BGP session on the Fabric Cloud Router. Actually, if I stop this and I show you the IP routers, there's no IP routers from the Metal server to the private subnet on AWS, which is a 172 subnet. So let me show you from the AWS portal. So I don't know if I'm running out of time, so I'm going to, in the meantime, I'm going to deploy these things that are needed to make this work. So let me go to the Fabric file, and we are going to uncomment these resources. Well, I think I'm having some trouble with my memory. Okay, now let's execute. Now again, Terraform apply. It should identify there are 4 new resources that needs to be created. And we'll say yes. So this is going to take like 1 or 2 minutes to have this configured. So if we go back to the Equinix portal later, we will see this connection status is provisioned an app. So now from the AWS console, so as I said, if I go to the VPC, in the default VPC, well, you can see the IP range is the 172.31.00/16, and for the subnets that we are working with, one of them is the 31.16 and the other one 31.0. So once we have this deployed and the VP session is up and running, we will see here in the IP routers on our Metal device that it will learn that route and it will be appearing here. So also in the meantime, I would like to show you that when I ping to this endpoint, it's resolving with the private address. So even if I'm still using the private interconnection with the private link, this is able to resolve that DNS externally. So it's using the internet access that I have in my Metal device to check to the DNS, even it's going to resolve with a private address. So the other problem is that right now I still don't have that private interconnection. So let's see. Well, it says that it's already deployed. So if I go back now to our servers and I refresh this, well, let's go to the connection. Okay, now it says that they are provisioned. If I move now to the active routers, well, this could take some minutes to learn all the routers, but we can force that with these load active routes. And if it's working, it seems it's working. Now you can see that we have learned both routes from the Equinix Metal server and the one coming from AWS. So if I go back to our Metal device and I try again to add that file to that object to our S3 bucket using the endpoint, well, it says that it's working. So now I can upload that file into the server, into the S3 bucket. So let's go to the AWS portal, move to S3. Well, you can see that it's the file it's already there. So, and well, with all this, that's I guess the end of the demo, and well, it could be perhaps interesting that if I try to do the same locally, you'll see it's not possible. Actually, well, I don't need that. I just trying to do the same, but without specifying the endpoint. Again, it is still saying that it's not possible because it's deny unless you're using the endpoint. And if I run IP route again, well, we see that we have learned that route that is coming from the AWS subnet. So yeah, that's all as part of the demo. I just want to mention before conclude that there are different ways to achieve the same. It's actually from you go to the Equinix Metal portal, you will see that when you're creating a fabric, if you try to create a new interconnection request, there is a specific option available to establish an interconnection to AWS. So it depends on your needs. You have also the option to interconnect directly from Equinix Metal to AWS. There's, as I said before, also we have the ability to use a network edge instead of Fabric Cloud Router. In that case, you will be able to use the BRF on Equinix Metal side. And also, I would like to mention that since like 2 weeks ago, something like that, we already have the Equinix Fabric Cloud Router available on the AWS marketplace. Honestly, I didn't try this yet, so if you have any question about that, I will try to answer, but I for sure I need to try that myself. So that's all. So thanks for having me.
Yeah, thanks for demoing all that. The marketplace Fabric Cloud Router, maybe that's next demo day, and we'll do it all through AWS or something. But yeah, thanks for joining us. I think it's really cool to see all that set up, including the routers and BGP routes and like all of this interconnection all through like Terraform configuration files is pretty spectacular. A lot of that used to be very difficult in manual processes, and it's really cool to see it being automated this far.
That's the reality. So when I've been preparing this demo, even if I know all the resources, the reality is there are a lot of components, and that's something tedious and complicated if you need to run this manually each time that you need something like that. So there you go. You have that template, and hopefully anyone tries to that out themselves.